First, the derivative of a constant is always 0. For example, for f of x is equals to 3, f prime of x is equals to 0. Next, the power rule. For f of x is equals to x raised to n, f prime of x is equals to n times x raised to n minus 1. For example, if f of x is equals to x squared, its derivative is 2x. Get it? Next, the constant multiple rule. It's just like the second rule, but there's a constant that goes with x. In this, you still find the derivative of x, but you won't touch the constant. For example, if f of x is equals to 2x cubed, f prime of x is equals to 2 times the quantity 3 times x raised to 3 minus 1. Simplified, it's 6x squared. Lastly, the sum or difference rule. It's as simple as this. If there are two or more terms in a function, all you have to do is find the derivatives of each term and add or subtract them up. For example, the derivative of 2x squared plus 3x is equal to the derivative of 2x squared plus the derivative of 3x, which is 4x plus 3. There you go. Now you're equipped with the rules to deal with derivatives problems. Now that you know how to differentiate, let's solve their problem. The formula of the rate of spreading is given already. 2x squared plus 6x minus 9. Finding the rate of something like speed and spreading is quite simple, because the rate is the derivative of the function. So to find the rate of spreading given the function, just find its derivative. Using rules on differentiation, we'll bring 2 and multiply with 2. Then x will be raised to 1. Our first term is 4x. For the second term, exponent 1 will be multiplied with 6. Then x will be raised to 0. So it is just 6. Our last term will be 0 because the derivative of a constant is always 0, so we won't include it anymore. Now that we have the rate, which is 4x plus 6, let's find the number of hours using the formula rate of spreading times time is equals to number of people infected. So our formula will be 4x plus 6 times x is equals to 3,780. 4x times x is 4x squared. 6 times x is 6x. 4x squared plus 6x is equals to 3,780. We'll transpose 3,780 to the other side, making it 4x squared plus 6x minus 3,780 is equals to 0. Let's use the quadratic formula to solve for x, which is negative b plus and minus square root of b squared minus 4ac all over 2a, where our a is 4, b is 6, and c is negative 3,780. Substituting, negative 6 plus and minus square root of 6 squared minus 4 times 4 times negative 3,780 all over 2 times 4. Negative 6 plus and minus square root of 60,516 all over 8. The square root of 60,516 is 246. There will be two values for x. First, negative 6 plus 246 all over 8 is 30. The second is negative 6 minus 246 all over 8 is negative 31.5. Obviously, there are no negative values for time, so the answer is 30 hours. There will be 30 hours left before everyone will be infected.
kind of bomb is that? Using derivatives to make it explode. Wow. Well, let's help them. You have learned how to solve the rate of something using derivatives. But in this case, it's not just a simple rate of speed, but the acceleration. But it's simple as well. If the rate of speed is the derivative of the function, the acceleration is the second derivative of the function. Confused? Well, let's talk about higher derivatives.
Higher derivatives are simply the derivatives of the derivatives. For example, to find the second derivative of a function, first find the derivative of the function. Then, find the derivative of that derivative. For a clearer example, look at this. If f of x is equals to 3x raised to 4 plus 2x squared minus 2, its derivative is 12x cubed plus 4x. Then the second derivative is 36x squared plus 4. Now you can deal easily with acceleration.